Hello and welcome to Chapter 1 to RH134, 41 RH134 training course. So Chapter 1, it's all about, they call it improving the command line productivity. That's kind of the official chapter name. But basically, this is going to be a short introduction to scripting. I'll tell you more about it in a second. And also the introduction to the grep utility. But stay tuned. Let's roll the intro and just go to work. And that's quite enough for the intro. So let's go directly to our console here. Here we go. So we have here the same machines we were using on the RH124. Let's just set up the microphone here. Yeah. So these are the same machines we left off with the RH124. And let's carry on. So like I said, this is Chapter 1, improving command line productivity. So in simple terms, you're going to learn how to set up simple bash scripts, okay? And also give you an introduction to the grep utility or the grep workflow in a way. You have seen me use the grep utility previously. Yeah, it's not the first time you see them. You see me using it, but let's just kind of get an official outcome to it. So put it in the official chapter, so we can just stick with it and carry on with our lives. All right, so simple scripting. So the way I see it, it's that in the script we will just put things that you want to do in repetition. So in the script, we basically at this level, at least at a very simple level, we are going just to put in the text file actions that you want to do, that we do in a more daily fashion, that we do in a more repetitive fashion. So instead of just typing the command in the command line, we're going to put it on a text file, that it will make it easier and less prone to errors when we want or need to repeat that task multiple times. Okay, so that's exactly what we're going to do here. We are going to learn how can we get the script going and do some simple tasks with it. And then maybe in the future, we will be able to kind of develop more about this subject. But let's keep it really simple at this point, and let's just dive into it. Let me just fix this. I have a wireless mic. I have a lapel mic here. I don't have it that handy, but maybe I will use it instead of this big one. But we will see. Okay, so here we are in our usual machines. Okay. And we just, this is just where we left off. And I have here a folder called scripts, nothing special. And I have here two scripts. So what makes a script a script? It's pretty simple, okay? So simple that I have here a text file called simple. Let's just get into it. It's just this. So what makes a script a script? Well, two things. What makes a script a script is that it's a text file, and the text file starts with this line. This is called a shebang. It's hashtag at the bang. So simply terms, this is hashtag and exclamation mark. This is called a shebang. And then we're going to tell the system what is going to be our shell, our interpreter. What does this mean? This means that we are going to instruct our shell to tell him or tell her, it depends, it doesn't really matter, to tell the shell which utility, which binary is going to be used to interpret the following commands. Okay, so basically, like I said, and I'm going to use the word basically a lot, but just bear with me. So you're going to instruct the system, in this case our bash shell, which is going to be the executable that is going to interpret the following commands. Okay, many things can be put here, but you're going to stick with a bash script. It's usually called a bash script because it's going to be our bash shell that is going to interpret all of this. If you want to know more about the bash, more bash shell details, you can go to the playlist about the RH124 training course, and where I discussed more about what the bash is. But basically, it's our bash shell is going to interpret commands, and we are going to tell the system which is going to be our shell to interpret the following commands. So if you create a bash script, it's going to be a bash script, because there are other shells. I will not discuss the other shells because you can just go to the RH124 and check it out. But if you build a bash script, it's going to be interpreted by the bash utility. Okay, so if you build a bash script, it's going to be built by for the bash utility. Okay, and that's what is going to happen. So if you use a script built for another shell, it will probably fail. But I digress. Since we are using the bash terminal here, it's going to be the bash, the interpreter. Probably there are two common ones. You have the bash and the shell, the SH. Never mind, I'm digressing again. So this is going to tell us who is going to be our interpreter. And in this case, we are going to instruct telling, okay, this is a bash script. Please use the bash utility or the bash binary to interpret the following commands. And a script, in very simple terms, which is the ones I'm going to use now for this chapter, is that these are just basically in sequence commands that we can use multiple times, and we can just invoke this. Instead of typing all of this in the command line, we can just put it in somewhere that can be very easily reusable. And that somewhere, it's a text file. So this is a simple text file just created. I call it simple.sh. Don't forget that in Linux, file extensions do not matter. Okay, in Linux, file extensions do not matter. So which means that this .sh here, it's just irrelevant. But it's like human beings, we put this so we can know what we are dealing with. So this is a shell script, and the shell is the bash. Okay, so you don't have to put it .sh. This is completely optional. You don't have to do this. But I mean, we are basic human beings, and this makes our lives a little bit simpler to know what type of file is. So it's a text file. I just VI'd into it. I don't need to VI into this because we have discussed VI in the RH124. Go back to that. I have an entire video about editing text files where I include the VI utility and the VIM and much more. Go and check it out. And like and subscribe, it really helps. And we're going to, this is a simple text file, just VI'd into it. And that basically, the trick, it's two things. You just put this line as for your first line. This makes this a bash script because it's going to be the bash, the interpreter here. And there's another thing we need to set up. Permissions, but we'll set those in a second to be an executable. So I don't have the execute permissions yet because I want to do it for you guys to see. But it's easily confirmable because usually executables show up as green. In this case, it's not. So it's just simple yellow because I chose yellow as my font color. But yeah, it does not have the executable permission, and that's fine because I'm going to set it later. So I want to show you guys how to set it or remind you guys how to set it because at this point, I highly recommend you when you go through all the videos on the RH124 so you guys can get more in depth into that. But I digress once more. So this is a text file, okay, and this text file is going to include some instructions, and you probably know some of these. Some commands here are going to cover them in this training. So on the RH134, so get subscribed to get notified. So here I'm going to do some actions in the scripts, and the following are as follows. I'm going to use the echo. We know what the echo does, but let me just do this without being inside the script. So this is going just to echo to the screen an empty line. And you should go to the RH124 training course that I just have in my playlist. This is going to echo to the screen something that is an empty line. But I'm using these two bigger than lines. I know for the English speaking people, this is not bigger than, but I like to say bigger than. So I will just keep saying bigger than. So two bigger than signs. This is going to output the output to the file on my home folder, which is called output.txt. So this means this is my home folder. Once again, to go to the 124 course to get more information about what this means. But in simple terms, this is my home folder. and it's going to be put on the file called output.txt. Okay. So as I'm starting with an empty line, I don't have to start with an empty line. I just want to create a file with some data into it. This is just cosmetics. Then I'm adding some hashtag lines. This is cosmetic. You will see what I mean when we see the final result. This is just cosmetics to make the file prettier to look at. Then I just type a header. So this is going to build a block of a header of a file, and this is going to append to the file called output.txt. And again, a new empty line. So all of this is just going to create me a header, something to be pretty to look at, to organize information. And don't underestimate the power of information organization, because this is going to make your life much, much easier in the long run. Then finally, I'll do the lsblk command, lsblk. This is going to, we are going to export this command in the RH134 training course, this video series. Like get subscribed to get notified. And this is going to output my storage information output. So instead of just putting this to the screen and losing the information, I'm actually putting this into a file that I can keep and check out later on. This one is going to make again a new header here. This is just a header to be organized. And then I'll just do the df-h. Let me show you this one. This is going to show me my free space on my storage, and this is going to be put on the file too. Okay. So this is going to generate something similar to, I can just show you guys here. This is going to generate something similar to this. This is the result. Okay, let me just put this a little bit bigger so you guys can see. So this is the content of the file. Again, I have here a header, and I have here a footer. So this is my decoration. This is going to show me what's coming next. This is my information about my block devices. This is going to show me what's coming next. This is information about my free space, and then ends with an hashtag line. So, like I said, this is decoration that can make our life much easier and much more comfortable to actually look at. Okay, this is for visual comfort. We never underestimate visual comfort. Because it can actually make your life easier. And this is going to generate this type of file, okay, which is quite nice. Okay, so this means that we are actually getting an output or a series of commands that instead of going out to the terminal and getting lost in time with no ways to get it back, I'm actually storing this in the file for future use. Okay, so this is a simple way to get the script going. Let's just check it out one more time. And this is kind of my header of following information, extracting information, and put it to a file. So that said, that were two things that would make a script a script. One, it's creating a text file and giving it these contents here, which is the case. And the second thing, it's making it an executable. So let me just remove this file to create a fresh one, okay? And if I look to my simple file, it's still not an executable. So one way to execute a script is to do the current folder / and the file name. This is going to execute this as a script /. And this is going to give me permission denied. Why? Because this is not set as a script. So in order to set this as a script, I just need to give it an execute permission to the file. And now I can use it as a script. There is no output because you guys know the answer. So let me just show the script again and let you guys think about why this is not getting any output to the screen. 3, 2, 1. It's not getting an output to the screen because it's simply put, it's getting all the output to a file. So that's why I'm not seeing anything to the screen. But if I check the file where I'm outputting to, you will actually manage to see the results. So this makes these actions, maybe I have to do this every single morning to check my server storage or any other reasoning around this. So I can do this every single time. It will be very repeatable. I will not fall into syntax errors or human errors because the script will just manage to do this the same way every single time. Very nice. This is a very simple script, but you can just tailor this to your personal needs. But there is more that you can do with the script. For example, I have here a thing called simple loop. Let's check this one out. And here I'm doing a simple loop, okay? And what is this loop doing? Let's analyze this. So we are telling the system to use the bash shell, which makes sense, okay? And one thing I did not mention in the previous ones. So if you start this with the hashtag, this is a comment, which means that it's not going to be interpreted as an action to execute by the script. It's just something like notes. It's like note taking. The exception is this one because it's a shebang. It has an exclamation mark right next to it, right? So this is kind of telling the system, okay, this is not a command to execute. This is a comment. So it means that I'm stupid. The system is going to look into this and it's going to be interpreted this as a comment. This is a commentary, which means it is just for humans to read and the system will ignore this for the most part, okay? So this is me telling myself, because the next time I watch I'll read the script, I probably won't remember why did I build it. But anyways, this is telling me that I'm going to execute this script for this following for the reasoning, and this is wrong. I typed this wrong exactly, so I can force myself to edit this out for you guys to see. So this is not the action that I'm doing. So I'm going to edit this out and execute this for the I'm going to correct this because this is not the reasoning. This is going to execute ping commands for my servers. Okay. Then I just save and quit and we are done. So this script, it's pinging my servers, okay? And my servers are called Rocky1 and Rocky2. So I could just ping by the command line. I could put here a simple script, something of this sort. I'm not going to save this. I don't want to keep it, but let's call it ping.sh. I could do the shebang if I wanted to. bin/bash. I can do ping blah blah blah, ping blah blah blah, and this will do this every single time, but I want to be a little bit more fancy because I'm doing a cycle. Okay, what is a cycle? It's a for cycle. It's a loop. It's a simple loop. Why I'm doing this? Because I can do for host. This means I'm going to set a variable called host, and the contents of that variable are going to be my server names Rocky1 and Rocky2. Okay. Then I will instruct the system what to do with these set variables. So now I have two variables, Rocky1 and Rocky2. What do I do with them? I'm going to ping those variables. The symbol, the money symbol here, the dollar symbol here, means please read the contents of this variable. So I just set the variable with these two values, and this is going to extract the variable data. So in simple terms, it's going to ping Rocky1 and ping Rocky2. Pretty awesome, if you ask me. Why am I putting this C1? Because this is going to ping it once. Because if you remember, if I use the ping command in Linux, it just tends to ping forever. It's an infinite action. It's going to ping until I break. So if in a script I do not put how many times to ping, it's going to keep the ping going in the background forever. So if I run this script 40 times, I will have 80 pings going. So that's bad. So I don't forget, if you are scripting or automating the ping command, don't forget to set how many pings you want to execute, or else it just keeps going forever unless you program some type of break. It's a really pain in the ass. So just don't forget to set up the amount of pings you want to execute. So this is going to ping Rocky1 once and ping Rocky2 twice, or once, twice in total. So one ping to Rocky1, one ping to Rocky2, and we can just see the result. So let's experiment this. So let's say let's ping simple loop.sh, and I have here one ping to Rocky1 with success. Sorry, here one ping to Rocky1 with success, and one ping to Rocky2 also with success. So I pinged Rocky1 once, and I pinged Rocky2 once too, and both of them were successful. So I'm happy with this. Of course, this can be a little bit more complicated. I can get into these situations of testing the results, if it's positive, if it was a good result or bad result. How do I do that? With the exit codes. Okay. Exit codes can be set or just interpreted. Okay, for example, I can do echo and spit out the contents of the variable $? This variable here, it's a system variable. You don't have to set it, it's set automatically. This is going to show what was the result of the previous command. So for example, if I do ping and I do something that doesn't not exist, you can see I have the resulting error codes too. If you go to the main page for the ping utility, you'll find that error code 2 means something went wrong. Number 1, it's host not found, or ping expired in transit. So there are many. You can go from exit code 0 to 255, where 0 is always success. So if I do ping Rocky1, I have success. So if I spit out the variable that registers the result of the previous command, being ping, being any other, 0 was success, which means like it was a successful command. For example, if I do an ls or a cat, in an echo, cat had no error, so error code 0. If I cat of file that does not exist, the error code will be 1. So 0 is always success, and 0 is always success. You can go to 255, but what 1 means, what 2 means, what 3 means, it depends on the command itself. But anything that is not 0 is an error. So if I see 0 as a result, it means that the previous command ran successfully. But don't forget that in the script, I can set my exit code, which means every time this script runs, it's going to return as a success. Even if it was an error, it's going to return as a success. That's just an option of you guys who can just set if you want what exit code to get. But in this case, every time I run this script, it's going to return with the success command exit code. Now I can just edit this out. For example, I can do simple loop sh. I can add here something like, I don't know, and execute the script, and this is going to include a ping to the 8888. Okay, so success for Rocky1, success for the other way around. Success for Rocky1, success for Rocky2, and success for the 8888. So I just have to add to the list, and the simple loop will include that value on the list and ping it too. This is very nice. This is very tailored, which means you can edit this out and add hosts or remove hosts, and the ping will just carry on doing its thing. You can do this for package installation to check if installation is set, it's not set, and everything else. So it's pretty great. So now you know. Let me just review this. You know how to do a simple script, which is basically put on the text file some common actions. Then you can do a simple loop with the for. With the for command for this, do this. Pretty simple, and it is very useful for the most part. And or you can also do more. For that, let's just do this in a more theoretical fashion. I don't know why my screen is not getting captured. Oh, sorry. Oh God, I want this one, man. Let me just see why this is not working as expected. Okay, it's fixed now. There we go. So here I have some other examples of things you can put on the script. For example, these are all bash things. Bash can do this. There is no need to install anything else. You can do this directly on the command line, or you can put this in the script format. So here I have some tests. Test means it's going to compare some values. It's a test command. And here we are just checking the end result. So greater than, if this is greater than, then it returns a 0. If it's not, it returns a 1, which means that 1 is greater than 0. Let me just clear this out. So basically, is 1 greater than 0? Yes, so no errors. Is 0 greater than 1? No, so it returns with a quote-unquote error. You can also do the same thing with square brackets. You can just do similar things with square brackets. You can compare strings. This is all bash thing stuff. This is nothing that you need to install. You don't need to install this. It's there for in the bash system for the longest time. Okay, and you also can use what we call the else's, the if then else sequence. I'm just going to mention this really briefly because this is not really needed for the EX200 course. A simple script, it's fine. You may get away with you may need a for cycle, maybe, but I don't see it being really needed. But you can just check this out in your own spare time. So this is an if. And if it can be useful if you want to compare stuff, if you want to test stuff with even further. So in this case, I'm doing something really simple. In this case, I'm using the systemctl to test if a service is active. If you don't know what the systemctl is or how it works, go and check out my RH134 playlist and like and subscribe there. So I'm just trying to see if the service is active or not. And I'm going to output all the outputs to add to the dev null. So I don't want this command to produce any output, just the error code. Okay. Then I'm testing to see if the error code is different than 0. Because, you know, if it's 0, it's going to be a success. If it's different than 0, it's a non-success. Okay. So, which means that if it's started, let it stay started. If it's not started, stop it. I know it's kind of dumb, but it's just an example. So this is going to test if the service is started, let it be. If it stopped, start it. I mean, it's kind of dumb. So if it starts, stop. If it stops, start. I know it's a little bit dumb, but it's just an example. So again, I'm testing to see if the service is active or not. Okay. If it's started, stop it. If it stopped, start it. It's kind of a dumb thing, but it is what it is. In this case, I'm testing multiple systems because I'm testing to see if MariaDB is installed or is active in this case, and Postgre if it's active. Since this I run the command twice. I'm setting the variable of the error code, of the exit code in a variable. So the execute variable for MariaDB it's set on a variable called MariaDB, and the exit code of the Postgres is set on a Postgres variable. So basically what I'm doing here is comparing. So if MariaDB is active, then it means that MariaDB is what installed. So if the MariaDB is active, then start MariaDB. If it's not MariaDB, it's MySQL. If it's not MySQL, it means that it's SQLite. So as you can see, these are the 3 most common flavors of databases in Linux: MySQL, Postgres, MariaDB, or SQLite. So these are kind of the most common flavors. But here I can test to see, okay, if it's one, then I'm just testing to see which services are active, and if they are active, then install them. So I just start over the active state or inactive state of each service. Then I can start the service, trying to guess which one is installed. Well, it's kind of again a little bit very simplistic, but it works. So if it's MariaDB, then start it. If it's Postgres, then start it. If it's not MariaDB nor Postgres, then must be SQLite and start SQLite. So it's kind of a dumb thing, but it works. So it's a way to get things done and get things working. So if you want to go back, that camera there. So if you want to go back to this last part and rewatch it or pause the video, I highly recommend. But to get ready for the RX200, just go back to my simple scripts and my simple loop, and you should be pretty good to go. Just to finish up this chapter here, let's just discuss a little bit of regular expressions in a very, very simple manner, because I'm going to be using and reusing regular expressions a lot throughout. So I'm going to be using it a lot. So let's just introduce this. So in the end of the video is going a little bit long now. So very simply put, regular expressions are ways to find a pattern in a very big mess. So in Linux, what is a mess? Well, text files are a very big mess. So in Linux, text files can be very messy. So what we're going to do here is going to be using we're going to use regular expressions to find a pattern in some mess. For example, let's check the simple script. It can be any text file really. So let's say I want to find this, for example, this word here, okay? What I can do, there are many ways to get this, but the way I do it is, one way to do it, I mean, is to get the file and redirect the output to the grep utility. The grep utility is one of many utilities that can deal or use regular expressions, okay? If you don't know what this output redirection means, go back to my playlist on the RH124, check it out. I have a whole chapter about this, and go and check it out and you can get more details. But basically, I'm getting the output of this file into the grep utility. Now I can use regular expressions. Regular expressions are a way to find patterns in chaos, especially in text. So, I'm sorry. So the easiest way to do this is, for example, I want to find the word bash. I just type bash. Pretty simple. Okay, and now I can see that bash, it shows up in two different lines in the same file. That's basically it. Of course, regular expressions can get really complicated really fast, but I will not get into much details about regular expressions for two reasons. First, I'm going to be using it a lot throughout this training session, throughout this playlist of the RH134, and it's something that is just going to happen. So I don't need to be too much detailed at this chapter yet. We can leave it for the chapters in a more natural form. Okay. So don't forget that regular expressions are also case sensitive. So if I do this, it will not find it unless, and this is a grep thing, a grep nice thing to have. I can do the -i, which means case insensitive. Okay. So if you do the -i on bash, it's going to be a case insensitive search. So it doesn't matter the case, this is uppercase or lowercase. And another thing I like to do is when I do this, see, I can see that he found bash in two different situations, but neither of these two, it's very obvious because he just found something in the big mess. So what I like to do is I do this and I do print the previous 3 lines. Sorry, the next 3 lines and the before 3 lines. Okay, this is going to be print what you found. Okay, but also print the previous 3 lines. I'm sorry, the previous 3. I said 3 and type 2. The previous 3 and the before 3 and after 3. So the previous 3 lines and the after 3 lines, which means it's going to give me some context about where this found. In this case, they are just one next to the other, which is, well, it is what it is. Let's use another file. For example, this guy here. Let's find for the word Rocky 2. For example, let's just do a simple like this, Rocky 2. There we go. I did it. Of course, I'm just getting the wrong file. So let's get the correct file. And this one here. You found Rocky 2 here, but if I tell him, okay, print me the previous 2 lines and the after 2 lines. Now here I have some context. Oh, okay, so you found it here, and the context is as follows. So by printing the previous lines and the next lines, I can actually see whereabouts the actual file or the actual keyword that I found is at. So I can get some context, or instead of being just a random word on a random file location, okay, I just get some context about where was this found, and at least for my mind, it's going to make things more easy to read. Sorry. You don't have to do the cat pipe. You can just grab the file directly. So there is no right or wrong. This is just a matter of comfort. Okay, there is no right or wrong. I like to do the cat's grab. I like to do it because that's the way I've been doing for years now. But you can grab the file directly. You just grab your pattern and then the file to grabs, and there you go. It's exactly the same thing. No problem. You can do the same thing, and you don't have to do the cat pipe. So one way or the other, it's fine. Never mind this one. I did a typo. The file it's in the end, but you can do the redirects or grab directly, and you should be good to go. There are many other grab things you can grab. but we will discuss more regular expressions as we go along. No needs to spend all the poker chips on at this phase. We will do it as we go along on this RH134. So this video is going on about long enough. That's enough now for chapter 1. Like and subscribe for chapter 2 and all the others. Go and check the RH124 playlist. Like and subscribe, it really helps. And I'll see you in the next one. Cheers, guys.